at A and B, how they are related. So it's a straight line which is making an angle some theta. This line you can extend. It is just moving with a constant velocity along a line AB. Then what is the angular momentum of the particle at A and at B? So LA greater than LB, LA less than LB. So any relationship can be determined. Just now we have discussed the basics things, no? So apply that concept. No, so I'll stick on to the basic definition. So the particle about what point? Angular momentum of LA, LB about origin. Find, I'll define the question clearly. Find relationship between LA and LB measured about origin. About O is what I'm going to measure the angular momentum of particle A and B and how much it is, that one. So if you, okay, let it be the only this much here. So I'll do one thing, I'll just go back to this one. So this is the R1 bar, this is R2 bar. And when particle is here, it will have velocity, constant velocity. The particle will move with a constant velocity. I think this much is there. Then, so after this, so let me extend back this line. So shall we take this is B? Then if this is theta 1, this is theta 2. What is the angle between particle when it is at A? So this will be R1 bar, this R2 bar. It will make some angle, you know. This is what theta 1, I'm defining it like this. If this is theta 1, if this is theta 1, can you say this is theta 1? Or simplest thing, let's use perpendicular distance about O. About O. So about O, when you go for perpendicular distance, this will become B bar and this will become velocity, you know. And B will be same for both the triangles. Either you go for this triangle or for this triangle, it will be same. Or this, instead of this theta 1, you'll getting confusion. Some are asking, sir, why you are defining here only? We'll do one thing. No, is there any angle between look at the angle. This angle, how much you can call? Say some theta 1. I'll write it here. It will be. This is okay. What is R1 sine theta 1? You can write it as B by R1. Sine theta 2, B by R2. And what is theta 1? Angle between R1 bar and V bar when the particle is at A. So how you define now? LAOZ. It should be like this. Angular momentum of particle at A when about axis passing through O and perpendicular to plane. This should be equal to how much? M R1 bar cross V1 bar. So M R1 V1 sine theta 1. What is R1 sine theta 1? It's B. And what is the direction? Clockwise. Similarly, LBOZ. What is R2 sine theta? Sine theta 2 should be equal to mv2b. What is the sense? Clockwise. Velocity is v, no? So what is the angular momentum of particle now? Yes, it is constant. So where do I can ask you, just go back to wedge constraint. You do get so many wedges, blocks moving, no? I'll just ask you find the angular momentum of them about an axis. You pick up any axis. Go back to again laws of motion. So many numericals are there, no? Wedge, block, moving. So wedge, what to do that one? Center of mass of the wedge. Wedge will be either square wedge, rectangular wedge, or triangular wedge. So you know where the center of mass. So just try to focus on what is the angular momentum of that moving wedge. About which axis? Whichever axis you want to prefer. Why you should waste time searching questions on this topic? I'll scroll down. So like this, anything can be asked. You have to be just be alert. Nothing big is there. Okay, we'll take the next one. Now, let's take the problem. I'll just introduce one. If there's an inclined plane, if the block is sliding on inclined plane, what can be the angle?